Today we're going to take a look at how to solve a different type of equation. A quadratic, but it's going to be of a little bit different of a form. So if you take a look at this, x squared plus 4 equals 0, we've learned in the past a couple ways to solve these. Number one, I think the easiest way is by factoring, right? So if we factor this, you'll notice we put an x squared here, a 4 here, right? X and x, and there's no middle term here, so the middle term here would be like 0x. We want these two to add up to 0x. So we could put a 2 there and a 2 there to get 4, but these would add up to 4x. If I make one negative, then these two would add up to 0, but this would be negative 4. So this is not factorable. So we can't solve this by factoring. Other way that we've learned how to solve this is by graphing. So to graph it, we can put it in our calculator, see what the graph looks like, and we have a parabola, but it never crosses the x-axis. So that means that there are no zeros, no real zeros. So today we're going to take a look at imaginary zeros. So real zeros we have when our graph crosses the x-axis. Imaginary zeros is if our function never crosses the x-axis. It's going to have what's called imaginary zeros. Mathematicians have created them, imaginary numbers, to quantify when we don't have real zeros. So I'm going to show you real quick how we get an imaginary number. If you take a look over here at the square root of negative 1. Now the square root of negative 1, there's no two numbers that multiply together to equal negative 1. Alright? It's impossible. If you put this in your calculator, you'll get an error. It's impossible to do. We can't take the square root of a negative number because one of the numbers has to be negative and one of the numbers has to be positive. So mathematicians have created this imaginary number for the square root of negative 1, and we use I for short, for imaginary. So 25 is equal to the square root of negative 1 times the square root of 25. Right? So the square root of negative 1 is I, and the square root of 25 is 5, so we can simplify this by saying it is 5i. I has the same properties as any other variable, like x or y or z. You use it basically the same way. So 5i would be the answer to the square root of negative 25. So if I want to know the square root of negative 8, I know the square root of negative 8 is the square root of negative 1 times the square root of 8. So the square root of negative 1 is I. Square root of 8, let's see, we have 2 times 4 and 2 times 2. So I have a pair of 2's, and left over is this 2 here. So 2 square root 2. But we can't forget about our I. So the answer to this would be 2 times I square root 2. We'd leave it in that form. Alright? So now let's go back to our previous problem. X squared plus 4 is equal to 0. We learned last lesson that we can use the quadratic formula to solve any equation. So we can use it to solve this one too. Since there's no middle term here, we'll say that A is equal to 1. There's no middle term, so B is equal to 0. There's 0 x's there. And C is equal to 4. It's going to make it pretty easy on us actually. So my formula goes negative b, so negative 0 plus or minus the square root of b squared, 0 squared, minus 4 times a times c, all over 2 times a, so 2 times 1. So now if I just simplify this down, we have negative 0, which is the same thing as 0, plus or minus the square root of 0 squared is 0, minus 4 times 1 times 4, so that's going to be minus 16, all over 2. Now a lot of people want to simplify this negative 16 over 2 here. We cannot do that because the negative 16 is inside the square root. So I'm going to simplify this square root of negative 16 just like we did before. That's equal to the square root of negative 1 times the square root of 16. Square root of negative 1, I. Square root of 16 is 4, so this is equal to 4i. So my problem here, I have 0 plus or minus 4i over 2. So I have two different equations now. I have 0 plus 4i over 2 and 0 minus 4i over 2. 0 plus 4i is just 4i. So I get 4i over 2, which is equal to 2i. Here I get negative 4i over 2, which is equal to negative 2i. So my zeros here are 2i and negative 2i, which means my factors are going to be the opposite signs of those, right? It's going to be x minus 2i and x plus 2i. Alright, so we always have zeros, we always have factors. Sometimes, though, they can be imaginary if our graph is not crossing through the x-axis, like this.